In this next example, we'll start with the second derivative of some unknown function and do anti-differentiation twice to get the original function. And we're going to have two pieces of information about the original function to help us figure out a specific function that satisfies these criteria. So starting with this second derivative, we're going to take the antiderivative of it. The antiderivative of f double prime would be f prime of x. So by the anti-differentiation rules we have, we're going to get that it's 12x cubed over 3 plus 6x squared over 2 minus 4x. So for this last one, notice that 4x is the function that when you take the derivative of it, you get 4. That's where this x came from. And of course, as usual, don't forget the plus c. Now notice, we're not given any information about f prime of x in the problem. So we actually are at a position where we can't figure out what this c is at the moment. But that's okay. We can still treat this c as a constant, and we can still keep going and just take the antiderivative of f prime of x, which will give us f of x. But actually, before we do that, I want to simplify my f prime of x a little bit. I should write it as 4x cubed plus 3x squared minus 4x plus c. Okay, now we're going to anti-differentiate f prime of x, which will give us f of x. The antiderivative of 4x cubed would be 4x to the fourth over 4, plus the antiderivative of 3x squared would be 3x cubed over 3, minus the antiderivative of 4x, which would be 4x squared over 2. And the antiderivative of c, where c is a constant, is just going to be cx. And that'll be a similar argument as we did over here when we took the antiderivative of minus 4 and we got minus 4x. So this last term will be plus cx. We still don't know what cx is, and that's okay. But we just took an antiderivative, so we need to add an arbitrary constant, which means we need a different letter because we don't know necessarily that it's going to be c. So I'm going to just call it capital D. I'm going to simplify a little and get f of x equals x to the fourth plus x cubed minus 2x squared plus cx plus d. Now, taking what we've done so far, we need to use our given pieces of information to determine c and d. So notice f of 0 will be 0 to the fourth plus 0 cubed. What am I doing here again? I'm plugging in 0 into this expression for f of x that I obtained. So we have 0 to the fourth plus 0 cubed minus 2 0 squared plus c times 0 plus d. This is a d here, not a 0. Sorry for my bad writing. If it makes a difference, I will edit this right now so it's super crystal clear. This is the letter D, this is the letter D, and this is the letter D, not the number 0. Again, the problem is saying f of 0 is 4, so all of this equals 4. What does that tell us? Well, 4 is this whole thing when we simplify it, but when we simplify this, we get that it's D. So D is equal to 4. Great. So now we can plug that piece of information into here when we use the other piece of info, which is f of 1 equals 1. Let's do that in a different color. So f of x, well actually, let's do f of 1 now. So f of 1 is plug 1 in for x everywhere here. And then just remember that d was equal to 4 because we just calculated that. So we have 1 to the 4th plus 1 cubed minus 2 times 1 squared plus c times 1 plus d, which is, as we found out, 4. And again, looking back at the initial conditions given in our problem, f of 1 equals 1. So I'm just going to write that this whole thing equals 1, which means 1 equals all of this, which means I have to simplify this. And I have then 1 equals, let's see, 1 to the 4th is 1, 1 cubed is 1, 2 times 1 squared, that's 2, and I'm subtracting it. So 1 plus 1 minus 2, that's nothing, plus c plus 4. All right, so we get 1 is equal to c plus 4. When I solve for c, I get that c is equal to negative 3. Putting it all together, the final answer is going to be f of x is equal to x to the 4th plus x cubed minus 2x squared plus, oh wait, c is minus 3, minus 3x plus 4.